All right, so today we're going to be talking about the number E, and yes, E is a number. It's about 2.72 right here, and it has to do with logarithms and natural logarithms related to the base of a natural logarithm. So we're going to treat E just like we do other numbers like pi, I. It can be treated like an X. So first we're just going to try to simplify with them so we understand how to work with E's. So they have the same base, so you would add your exponent. Sorry, it looks kind of dark here. I'm going to try to move this down, see if it will lighten up a little bit. So this becomes e to the 7th because I just added, adding those. And then right here, we divide our numbers. So it becomes a 2, and you subtract your exponents. So 3 minus 2 is 1. So we get e to the first. You don't have to put a 1 because it's there. This, you distribute your 2 to each of them. So you'd have 3 squared times e, and then power to a power, you'd multiply them. So that would be 9 e to a negative 8x. I'm fine with you leaving it as negative 8x because that actually means something. But you can also put it on bottom if you like that better to make it a positive exponent. So here I'm going to add up all three of these. So that's an x minus a 3x plus a 5. So it's really just a negative 2x plus 5. You don't have to simplify it any further than that. You just add those up. So this, there's no number, so you add the 3. And then you're going to add your exponents here. So negative 2 and 6 is a 4. Divide my numbers as a 5. And here I'm going to subtract my exponents. So 1x minus 5x is negative 4x. So again, you can leave that with like that for me. If you have a problem, then you can put it on bottom like that. So using a calculator for these, just make sure you know where your E button is. So on my graphing calculator, your E button is right above your LN. It's in the same spot for the red ones. I don't think I have a red calculator up here on this video. Let me check real quick. Oh, I do. Okay, hon. And so there's that. On the this calculator here, here's the ln. So your E is right above it. So you hit second ln, there's your E. And then on this, you would just type a 2. And here you can just type a 2 either way. So you can see both times 7.4, we'll say. And then if I'm going to do E to a negative 3, and that's 0.0498 or something, or 0.0. So the point here is even a negative exponent does not give you negative values. It just gives you numbers closer and closer to 0. So the growth and decay are the same as the other one. This is 2.7 to an x, so that's bigger than 1. So that makes it a growth. This would be 1 over 2.7, which would make it less than 1. So e to a negative x, e to a negative x makes it a decay. So on the back, we're going to go ahead and, on the last, I just realized my last video I didn't state my domain and range. Oh well. So I'm going to go ahead and state my horizontal asymptote, my domain and range, and graph them. So this time I'll try to remember them all. So my y-intercept is at 2. This still, e to that number is still bigger than 1, so this is a growth. So I'm going to have my growth here. My asymptote is at 0. So I would have started this at 4 and made it a growth, but then you have to go down 4, which is also where your asymptote goes at whatever your k is. So I'm going to go down 1, 2, 3. And make sure your y-intercept goes to the correct part there because you want to make sure it looks wide enough. You don't want to make a little tiny one down here. This y-intercept is negative 3. So this negative makes it a decay. Why did I just make this a decay? See, if you guys had been in class with me, you could have said, hey, why did you make that a decay? Sorry. It is a growth. All right, this one's a decay down here, and it's going to go up 1. So my y-intercept is at 1. Move my graph up 1. And look, I made this one a growth now, and it needs to be a decay. Good thing I got an erasable pen. If you guys are watching this, you're probably thinking, what's wrong with her? All right, there we go. So it is that, a decay, and y equals 1. This is y equals 0. It is a growth, and we're going to move left 3, the opposite. So normally I would make a graph that looks like this that goes up. So instead I'm just going to move it over right there and do it. So my domain for all of them, because I'm lazy, I'm going to say domain for 1 to 4 is negative infinity to infinity. All right, so domain on all of them, know that. The range on this is just your k to infinity. Then we're parentheses, 0 to infinity, negative 3 to infinity, 1 to infinity, and 0 to infinity.